Welcome to Vision Plus and welcome back to the Singapore Mathematics. Today we are going to see how we can use the given expanded equation of a circle to find the center and the radius of that circle. So example 1 says, find the center and the radius of the circles below. Okay, the circle is given by x squared plus y squared plus 2x minus 2y minus 4 equals to 0. This is the given circle in the expanded form. Now, how can we find the center and the radius of this given circle? The center has coordinates A and B, and then now the radius R. So we are going to find A, B, and R. Now, what do we do here? We compare this given equation to the expanded equation of a circle given by x squared plus y squared minus 2ax minus 2by plus c equals to 0. This is what you must keep in your mind when you are dealing with expanded equation of a circle. Now from here we are going to compare terms and coefficients. X squared corresponds to x squared, fine. Y squared corresponds to y squared, fine. That also means that positive 2x corresponds to negative 2ax. Those two terms correspond. That means also the coefficient of x here corresponds to the coefficient of x here. The coefficient of x in the given equation is positive 2. The coefficient of x in the formula in the expanded form is negative 2ax. So these coefficients corresponds because the terms also corresponds. The same apply here. Negative 2y corresponds to negative 2by. The coefficient of y in this case is negative 2. It must correspond to the coefficient of y here, which is negative 2b. And then the next term is negative 4. Negative 4 corresponds to positive c. And then 0 and 0 they correspond. So the choice is yours. If you want to compare terms, you actually get the same answer as comparing coefficients. So in this case, I'm going to compare coefficients so that our work is lighter. So I'm going to say comparing coefficients, which is the same as comparing terms. Now, we are going to compare the coefficients of our interest, where we have the unknown that we want. Like here, we want A, B, and R. So our interest will be where A is, B is, and R is. So in this case, you are seeing clearly that the coefficient of x here, positive 2, corresponds to the coefficient of x in the formula, which is negative 2a. Therefore, 2a, no, sorry. Yes, it is fine. Actually, we can begin with this side, but let me begin up here. Positive 2, which is 2, corresponds to negative 2a. That is by comparing coefficients. Positive 2, which is a coefficient of x, corresponds to negative 2a, which is also a coefficient of x. And from here, you can find a. Just divide both sides by negative 2, both sides by negative 2. Therefore, our a is negative 1. A equals to negative 1. That is a. Still, for us to find b, we're going to compare the coefficient of y. The coefficient of y in this case is negative 2. Also, negative 2, which is the coefficient of y, will correspond to the coefficient of y, which is negative 2b. Take the sign before the term or the coefficient. This means that here we shall have negative 2 corresponding to negative 2b. Let me say both sides by negative 2, both sides by negative 2. That means here your b becomes positive 1. B becomes positive 1. After getting a and b, those are coordinates of the center. So we just say center is negative 1. This one should be positive 1, please. This is positive 1. Negative 2 divided by negative 2 is positive 1 and 1. So the center has coordinates negative 1 and 1. And then going to the radius. If you look at this expanded equation, there is nowhere where we have the radius. Okay? But on comparing terms, you see that negative 4 corresponds to C. So also C is negative 4 because negative 4 corresponds to C. That means negative 4 equals to C. It means C equals to negative 4. The two sides are the same. So now you have C here, but you don't have R. But there's a formula given that C is A squared plus B squared minus RI squared. And we have C, we have A, we have B, which are here. A, B, and we have C. So we can substitute for A, B, and C, and then we find R. Therefore, let us substitute here. What is C? C is negative 4 equals to what is A? A is negative 1. But the formula says square plus what is B? B is 1. And the formula says square minus R squared. So we're going to square these two terms. This means that here negative 4 equals to, if you square negative 1, get 1 plus 1 minus R squared. This is now a simple algebra that it's in a 4. You can solve it. So I'm going straight to say, therefore, after collecting the like terms, which you can do. Okay, let me collect like terms just for this case. I'm going to carry negative R squared that side so that it becomes positive R squared equals to 1 plus 1 is 2 plus this 4 bit. This 4 becomes positive after crossing. This negative here becomes positive. Therefore, this is 6. Therefore, R becomes the square root of 6. That is R. Let me prove a bit. 6 going to have 2 minus 6. Yes, it is correct. So this is R. So therefore, radius R is root of 6 units. So the center is negative 1, 1, and the radius is root of 6 units. And it is correct because if you try to prove, if you use this center and you use this radius, and then you find the expanded equation of a circle, you find this answer if your working is accurate. That is for part A. Then for part B says that we are given x squared plus y squared minus 4x plus 6y minus 4 equals to 0. Still, we are going to write the expanded equation of a circle and we compare. So that we find A, B, and R. That is what we know that we are finding. So we are finding center A, B, and then R. So what do? We write the expanded equation of a circle, which is x squared plus y squared minus 2ax minus 2by plus c equals to 0. It must be this format. It is minus here, minus here. If you change it to plus, you fail it. You get? Your answers will be correct, but with opposite signs, which shifts the circle to another location on the Cartesian plate. So on comparing coefficients here, or comparing terms, comparing coefficients. Why are we saying what terms? Because at some point we shall compare terms, but at some point we compare coefficients. So you can say comparing terms, comparing coefficients. So x squared corresponds to x squared, y squared corresponds to y squared. That means the coefficient of x, which is negative 4, will correspond to the coefficient of x here, which is negative 2x. Therefore, negative 4 equals to negative 2a. Yes, it is not 2x, it is just negative 2a. So negative 4 corresponds to negative 2a because the coefficient of x. Then you say both sides by negative 2. And after dividing each side by negative 2, you find that a is 2. That is a simple algebra. Still, you are coming to compare the coefficients of y and y. So that means 6 corresponds to negative 2b. 6 is positive here. So 6, which is positive, equals to negative 2b. Both sides by negative 2. And after dividing each side by negative 2, you find that our b equals to negative 3. After getting b, then you say that the center is 2 and negative 3. That is where the circle is centered. Those are the coordinates of the center. And then, comparing the last term, negative 4 corresponds to 6. Also, c equals to negative 4. What do you know? You know that c is given by a squared plus b squared minus r squared. So, where is c? C is negative 4. So, you put here negative 4 equals to, what is a? You cannot find the radius before finding the center. That means if you find a wrong coordinates, if you find wrong coordinates of the center, you get a wrong radius and you fail. So you must use the coordinates of the center, for which a is 2 squared plus b is negative 3 squared minus r squared. Here I'm not going to waste time, I'm just going to say the value of r, because we're going to square 2 square negative 3, you carry them to that side of the equation, divide them by negative 1 and find the answer. But you people, okay, let me finish it. I will have the negative 4 equals to, here we have 4 plus 9 minus r squared. If I carry r squared that side, it becomes positive. Therefore, my r squared becomes 4 plus 9, 13, plus this 4 becomes positive, plus 4. That means r squared equals to 17. So r equals to root of 17. Therefore, the radius are 17 units. Root of 17 units. That is the radius in example B. Before you leave, prove your answer. 2 squared plus negative 3 squared is that negative 4 minus answer. It is that divided by negative 1 root. Yes. So the radius is root of 17. So this is how you compare coefficients in part A and part B. And now going to part C. Part C is given as x squared plus 6x plus y squared minus 2y equals to 6. If you look at this, yes, it is an equation of the circle, but it is not in the required form. So we just simply need to rearrange. Why? Because the equation of the circle is x squared plus y squared, and then a term in x, a term in y, plus c equals to 0. But you can see here it is equal to 6. So let us rearrange it to meet the general form of the equation of the circle. So we shall have x squared plus, I bring y squared, then I put plus 6x minus 2y. In the equation of the circle, it is equated to 0. So we must carry the 6 this side so that it becomes minus 6 equals to 0. Now this format now can be compared to the equation of circle given by x squared plus y squared minus 2ax minus 2 by plus 6 equals to 0. Now they are in the same order. X squared, y squared, the term in x, term in y, c, and equals to 0. So on comparing the terms, comparing terms or coefficients, comparing coefficients, since I've started coefficients, let me finish with it. Our markers. So when we compare these coefficients here, we shall see that x squared correspond, y squared correspond. It means here the coefficient of x, which is 6 here, corresponds to the coefficient of x, which is negative 2. Therefore, 6 equals to negative 2a. Okay, negative 2a. Then you solve it, you find that a equals to negative 3. Also, therefore, comparing the terms in y, coefficient of y, which is negative 2, corresponds to the coefficient y, which is negative 2b, negative 2b. We solve by negative 2, and then we find that b is positive 1. After getting a and b, then we put the coordinate that the center is at negative 3 and positive 1. That is how we find the center. Still, we are going on to compare. Negative 6 corresponds to C, please. I don't know how I got confused here, but in the general equation we have, this is plus C. Okay, plus C. So we are saying that negative 6 corresponds to C. So also C equal to negative 6. What do we know? We know that C is given by a squared plus b squared minus r squared. So we substitute for a, b, and c. C is negative 6 equals to, what is a? A is negative 3 squared plus b is 1, but we are squaring it, minus r squared we are looking for. That means we shall have negative 6 equals to 9 plus 1 minus r squared. If I carry negative r squared this side, I have r squared equals to 10 plus 6. This is 10. If 6 comes, it is positive. That means r squared equals to 16. Take the square root, it means r equals to 4. Therefore, the radius in this case, the radius r is 4 units. So, this is the center, and that is the radius of the circle in part C. If you use this center and use that radius to find the equation in the expanded form, that is, if you substitute for them here, you'll be in position to get back that equation. And that proves the answer to be correct. So this is the solution to example